Now we will see the problem 1, and first of all we will know what is the desired answer of this question. Now let's see the question number 1. In question number 1, it is saying that there are two large conducting sphere carrying charge Q1 and Q2, and this sphere is separated by a distance small r. Now, according to Coulomb's law, the force on this two sphere is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by r square. Now the question is the force between these two spheres is exactly the 1 by 4 pi epsilon 0 Q1 Q2 by r square or not? So in this problem you are asked whether the magnitude of the force is exactly equal to the given force in question or not. Now we know in Coulomb's law that the force acted between two charge Q1 Q2 is 1 by 4 pi epsilon 0 Q1 Q2 by r square, but there is a limitation in Coulomb's law. Now what is the limitation? The limitation in Coulomb's law is that this law is only applicable for point charge, but here there are two spheres, okay, and the charge on the sphere is Q1 and Q2. Now if the two spheres are staying a distance r apart, then due to induction there will be a redistribution of charge on the sphere, and so the exact amount of the force will not equal to 1 by 4 pi epsilon 0 Q1 Q2 by r square, as this is not point charge. Okay, do you understand this or not? Now we will go into the problem number 2. Let's see what the problem number 2 wants to say here. In the problem number 2, there are 4 identical points which are placed at the corners of a square. Okay, a fifth point charge placed at the center of the square experiences 0 net force. Now the question is this a stable equilibrium for the fifth charge? Explain. Now if you consider a sphere and 4 charges are situated at the 4 corners of the square, and a fifth charge is placed at the center of the square, then the fifth charge will be staying at equilibrium. Now the question is this equilibrium is stable equilibrium or not? Now first of all we have to know what do we mean by equilibrium. Okay, so equilibrium is the state of a particle where if you apply force, then after the removal of the force it will gain its equilibrium position, or it will move towards its center. But in this case the charge Q1 and Q2 are situated at the center of the square. Now if you displaced the charge by application of force, then it will not come into the equilibrium center, and it will come at equilibrium center for a very special displacement. So this equilibrium is not the stable equilibrium. Okay, do you got this or not? Now we will go into the next question, that is question number 3. In question number 3 you are saying that there are two identical spheres 1 and 2, denoted by 1 and 2, and there are another sphere which is denoted by 3. These 1 and 2 spheres are initially at a small distance apart and having charged. Now if another uncharged sphere, that is the sphere 3, is placed near the sphere 1, and after removing this sphere from the sphere 1, if it placed near the sphere 2, then at the final state what will be the resultant force acted between the sphere 1 and 2. And there is a diagram which is shown in the question. In the question there are basically 4 diagrams denoted as A, B, C and D. Now if you carefully observe the diagram 1, in that diagram the sphere Q1 and Q3 are separated by distance. In the second case, that is figure 2, another sphere Q3 is placed near to Q1, and in the third case the sphere Q3 is placed near to the Q2, and in the final stage the sphere 1 and 2 are separated by the distance which it was separated at the initial state. Now to calculate this effective force between these sphere 1 and 2, we have to know a principle of distribution of charge. We know that from the principle of distribution of charge, if two body, one is charged and another is uncharged, are touched with each other, then the charge will distributed uniformly between these two body. For example, if Q charge is situated at sphere 1 and the uncharged sphere Q3 is touched with the sphere 1, then after touching the charge will be divided into these two sphere, that is the final charge on the two sphere is Q by 2 and Q by 2. Similarly, after the charged by induction the sphere Q3 is touched with the sphere Q2, then at initial state the sphere Q3 has charge Q by 2 and the sphere Q2 has charge Q. Now the total charge in this two sphere is Q by 2 plus Q is equal to 3Q by 4. 3Q by 2, and the charge on this two sphere will be divided by 2 and the charge is 3Q by 4. Okay, so we get the final charge on the sphere 1 and the sphere 2. Now if we put this charge in the Coulomb's law, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square, then we will get the resultant force. So F is equal to K Q by 2 3Q by 4 by R square, and after calculation we will get 3K Q square by 8 R square is equal to 3 by 8 into 88 is equal to 33 milli-Newton. So this is your answer to the question. Okay, hope you all understand this. Okay, let's see the next question, that is question number 4, and this question you are saying that there are two metallic blocks resting on a frictionless horizontal surface and are connected by a light metallic spring. Okay, and the spring have a spring constant K, and the spring has unstretched length L0 as shown in figure, and a total charge of capital Q is slowly placed on the system, causing the spring to stretch an equilibrium length L as shown in figure. Determine the value of Q assuming that all the charges resides on the blocks and that the blocks are like point charge. Okay, now let's see the solution of this problem. We know that in the equilibrium condition, if there are multiple forces are acting, the resultant forces will be 0, is not it? So here there are two forces acted. The name of the two forces, one electrostatic force and two the spring force. Okay, now as these are in equilibrium condition, so these forces are equal and opposite. So you can write FEL is equal to FSP, where FEL is equal to electrostatic force and FSP is spring force. Okay, now let's see the free body diagram of the problem. The free body diagram of the problem is depicted in the figure. Now carefully observe this free body diagram. Okay, in the free body diagram, in the left side there is a block and in that block there are two forces acting. One is electrostatic force FEL EC and another is F spring. So these two forces are acted in opposite direction. Similarly, the block B, if you observe the block B, in that case there are also two forces. One is spring force and another is electrostatic force, and these two forces will stable the spring into equilibrium position. Okay, so from the condition of equilibrium we can say that F electrostatics is equal to F spring. So here the electrostatic force can be written from the Coulomb's law as 1 by 4 pi epsilon 0 q by 2 whole square by L square, as the total charge Q is distributed on the two block by the amount of q by 2 and q by 2, and this is we know in our previous problem from the principle of distribution of charge. Okay, so after calculation you will get that this q square is equal to q square is equal to 16 pi epsilon 0 kl square into L minus L0, and we know that the spring constant K is force per unit length. So from there we can say the spring force F is equal to minus Kx, where K is spring constant. Okay, so this spring constant and the spring force we learn in our class 11, and after calculation you will get the result Q as pi epsilon 0 k L square into L minus L0 to the power 1 by 4. So this is your final answer to this question. Hope all of you understand this question and the problem and the solution of this problem. Now if this video is helpful to all of you, then please like the video and subscribe and press the bell icon that the all videos comes to you first, and of course share these videos to your friend. Thanks for watching.